Alright, it started. So yeah, you can tell these classes are classes because they have capital letters at the beginning, and then for methods, it's a little bit different. Methods have lowercase letters like this, and they have parentheses. And that's just like the default naming convention. And parentheses are required for every class, or for every method rather. So there's that. So I like to give this basic analogy of buildings when we're talking about classes because it's pretty accurate actually. So when we have a blueprint, right? When we have a blueprint like this will act as our class because this is what we're using to define some kind of like physical object that will be made. And in Java, whatever we make from objects or from classes, those are called objects. And in real life, that's the same case. Whenever you make something from a blueprint, you're making like a physical manifestation of that. So you can see like we have these houses here. Those could represent like the objects that are manifestations of these blueprints in real life. So that's like a fairly good example of classes and objects. In the case of computer programs, these houses would technically be stored in memory. So in real life, it's like different, but the analogy still holds as the main idea. So I've defined like a building class right here, which would kind of be what you would represent with this blueprint. So we have like some data for those houses and attributes like the number of bathrooms, number of bedrooms, and the color as well. And notice how these are actually not static variables. So we'll be talking about the difference between static and non-static today. In the case of static variables, these are not static because they're different for every house, right? So this house might have a different number of bathrooms and bedrooms compared to this house. And the color is different, obviously, for all of these. So each house has like each of these properties. Alright, let's go on. So when you create a new object of a class, what happens? Well, we'll have like a initial... Oh, someone raised their hand. Do you have a question? Why'd I make it private? Because in Java, our field variables, they will always have a private access modifier. Because I touched a little bit on this earlier in one of the previous classes, but basically when we have field variables, we make it private because we don't want other people accessing and modifying them without like us giving clear consent to them that we want them to be modified. And the way that we would give consent, the way that we would allow other users who are using our classes to access and modify our field variables would be through methods. So we'll look at how we can use methods to access and modify these field variables as well. So I hope that answers your question. Like, let me know if it doesn't, but that's why we use private for field variables. And these are field variables, right? Because they're inside the scope of this class, but not inside a method. So anyways, when we create an object of a new class, what we're doing is we are calling the constructor, right? We have this thing called a constructor. This is not something that we've been using earlier in our previous programs, right? We've always been doing work in the main method for every class. And then we start our program executing in main, right? We make the scanner instance in main, and then we call our prompt. We write a prompt to the user, and then we get their input. And for all of those, we're doing it in main. But when you're working with Java, you'll always be using objects and classes like very dynamically. And for that, to be able to do that, you need to be able to use constructors, which are essentially like the initial state of a class. They help you define the initial state of an object. So I gave an example here. Now I've written a constructor for this building class. In this case, what we're doing is we're initializing these field variables. So these field variables, they're not defined here. They're only declared because we're not setting them equal to anything, right? we only put like a semicolon, and then that means that we're only declaring them. So in this case, we need to be able to define them in some kind of way, right? And we can do that using a constructor. So the way we write constructors is by putting our access modifier, which is public in this case, and building, which is the name of the class, and then we put parentheses right after that. The reason why this is public and this is private is because other classes can actually call this constructor, right? When we're making a scanner instance, we're calling the constructor. When we say scanner keyboard equals new scanner, that new scanner will call this right here, but for the scanner class. So when we say new building, we would be calling this constructor. And we can give parameters to constructors. Now these parameters will help us define the initial state of whatever object we're making, right? Whatever building we're about to construct. So in this case, we have the number of bathrooms, the number of bedrooms, and the string of the color. And this helps us give outside information to whatever this object will be defined as, or rather the attributes of the object and what they will be defined as. So we set that, the way that we do that is by setting the field variable equal to the parameter. So like this. And when you would call it, you would say like new building, and then you would put a number, and then a string, and then those values would be set equal to these three right here. And effectively we've made the building object and we store that in memory. So that's how we can use, like I wrote here, constructors can initialize field variables with parameters to define the initial state of the class. So yeah, that's how we can make objects with the initial state that's defined by us. Now let's talk about methods. So we know how methods are able to perform actions, right? They're able to do work by definition. But these methods often require input or tools to run, and the form of, or rather the name of these inputs is called the parameters, right? When we pass in outside information from the world to our program, we're using parameters. And then I put in like some fill in the blanks here, so let's see what this says. So methods can give a result back to the place where it was called by, returning, or they do not give anything back. And in the case where they don't give anything back, the return type would be void, right? We looked at this earlier. So when we're calling a method, and by calling I mean running the method, when we run the method, we can define like a return type. That return type means that whatever we want to output back from the method, whatever the method like wants to give back, and this could be like useful information like a calculation that the method does. Like let's say we want to give that calculation back, that will be the returning value from that method. So we're doing this thing called returning, and that's an important concept in computer science to know. And when we don't return anything, then the return type would be void, and that's something that we have to specify. So we write multiple methods to organize code, and so that program functions can be used multiple times in multiple places. Like say you wanted to perform that calculation multiple times, right? You don't want to write the same code over and over again. What you want to do is you want to write one method and then run that method over and over again whenever you want to run that calculation, right? So this will allow you to be dynamic with your code, and effectively there's this thing called like polymorphism, which allows you to like reuse methods. It's a concept of reusing methods, and then reusing methods will enable that. And we talked about polymorphism a bit in the first class actually, but we'll return back to it later on. So yeah, there's that. When we're making methods, right, we have first the access modifier. This is our public or our private. In school, usually you'll make public methods. You won't really use private methods because, well, the teacher will want to see your code. I mean, not see your code, but like access your code if they have like a grading system. So you'll make public methods usually. You'll then have the return type, right? This is your public, I mean, your void, your data type, like integer, boolean, double, string even. This can be a class, so you could return a class object. That's your return type. And then you have your method name, right? This can be anything you want. Generally, you should make it lowercase. Actually, you should always make it lowercase because that's the naming convention. And you don't want your methods to be confused with classes. So yeah, make it lowercase, and then you have your parameters, which are the outside information that you pass into the method. So there's that. Now we can move on. Alright, let's first, I put this here so that we can identify the characteristics of methods. So what are the methods here? Well, we have print my name right here, and then add 2 multiplied by 4. This is an example of a calculation that I was talking about. Like, say you wanted to do this multiple times, you could just define a method like this and then keep calling this method over and over again to like enable that principle of polymorphism. So those are the methods. Our classes, what are some classes here? Well, I'll let you guys identify one. So let's see if you can identify 1 or 2 of the classes. Like, just type it in the chat if you see any. Yeah, system is one of the classes that we have, and system is calling this method. But we also have string right here. So you can identify these are classes because they have this green highlighting, but mostly because of the naming convention, right? They have capital letters. And then our parameters are name and num. So num is like short for number. So whenever you see that, it just means number. In this case, we're using the parameters to implement some kind of feature of the method. So is int and void classes too? Int and void, these are not classes. These are, well, void is like your, as I said before, it's like the return type, and then int is a primitive type. So these are like built into Java, which means they're not like defined as classes. So yeah. How many type-alongs? Well, we'll have like one program I planned for today. It's gonna be later on, like at the end. So we'll be using like principles of classes and objects in that. Alright, let's move on. Static versus non-static. So static means that whatever we define as static, like our method or our variable, our field variable, they belong to and are shared by all objects of the class. So let's say we had, I think I put an example here. Did I? No, I didn't. So we have, let's say we have like a human class, right? And let's say we wanted to define a field variable called number of arms. So in the chat, would that be static or non-static? Like, using this definition of being shared by all objects of the class, being shared by all humans, that is the number of arms something that can be static, like in general? Like, just type yes or no in the chat if you think it could be static. If like, let's say we wanted to define a field variable, and let's say we wanted to call it number of arms in general, would you think that would be static or non-static using this definition? Yeah, it would be static because, well, most humans have 2 arms. There are maybe like a few that don't, but in general, humans have 2 arms. So in that case, yes, we would make it static. You guys are correct. However, if we wanted to define a variable called like favorite color in the field variable, do you think that would be static? Yes or no? Like favorite color? No, right? Because everyone has a favorite color, a different favorite color, that is. So that's an example of how you can decide whether a variable or a method would be static or non-static. Like, see if it's shared by all objects of the class, and if it is, then it would be static. And then we call static methods using the class name. So I put this here because there's a class called math. I think I put it on the next slide. Math right here. And all of these are static methods, meaning that every object of the math class will share these methods. But it wouldn't make sense to create an object and then call the method, because for every single object the method would be the same, right? So in Java, what you do is you call the method using the class name itself. So you say math.max and math.min, and we'll talk about what these methods do, so don't worry about that. But the main point here is that static methods will be called using the class name rather than creating an object and then calling the method using the object name. However, with non-static methods, or non-static methods and field variables, each object has its own method or variable of that type, right? Like every human has a different favorite color. So then we call that using the object name, like bob.ridebike, but we also saw scanner.read next line or something like that. Scanner.nextLine. And in that case, we're creating a new scanner instance and then calling that method. So we'll be learn how to use Unreal Engine. Unreal Engine, that's like way beyond the scope of this class, so we'll not be doing that. If you want to do that, there's like a lot of good tutorials on YouTube, but no, to answer your question. Alright, so yeah, math class, all of these are static methods. So these are useful classes for mathematical calculations and operations. So if you wanted to find a maximum of two numbers, you could say math.max, and then as parameters you would pass in like a and b, and then a and b would be two numbers. You wouldn't literally pass in a and b. I'm just saying a and b because those would be variables. So let's say math.max 1 and 2, that would return 2, because returning is like the result of that calculation or whatever operation that the method is doing. So in that case we return 2. Minimum, or math.min, gives you the minimum, square root gives you the square root, and then math.random, we'll talk about that, because this is like a fairly that's a thing that takes a fair amount of time to get used to. So yeah, math.max a and b. Suppose a and b are variables, then we would return the maximum of a and b. Square root returns the square root of whatever number we put in here. And then math.random, this will generate a random number between 0 and 0.9. So how would you use this to make like a random integer, for example, between like, I don't know, 5 and 14? Well, we'll look at it first. So usually we manipulate the output to get a random integer. This means that we perform operations on this method and use that to essentially get our desired range for random numbers. So let's look at this first. Let's ignore this int in parentheses. This might seem kind of weird, but look at this part first. Look at the right side. So you see here that we have math.random times range plus start. What you can immediately notice first is that we're treating this math.random like a number, right? Like we're multiplying this method, this call to this method in the math class by some kind of variables right here. So range and start, just assume they're variables for now. But what you should notice is that we're using this method like a number, and that's because this method returns something. So when it returns something, it's like you can substitute whatever value it returns into wherever it's being called. So let's say math.random return like 0.0, for example. It just returns 0. So then you could substitute 0 in here, and then it would be 0 times range plus start. Let's say range was like some value, it had some value assigned to it, So 0 times range would be 0, and then we would have start, simply start, because this entire part would evaluate to 0. Now let's say we have like this int thing. Now let's look at the left side and see what this does. What this int is doing is, this is what is called casting. So what this is going to do is, it's going to truncate the decimal. It's going to remove everything after the decimal point and then keep whatever we have in the beginning. So let's say we had 0.5 as the value of start, right? And then this entire expression, this first part, evaluated to 0. Math.random time range, that was 0. So then we would have int in parentheses, and then we would have start. So then in that case, we would truncate or remove everything after the decimal point, and then we would have 0 as the result. In this case, math.random times 10 plus 5. Let's try to find what the range of this is. Like, what are the range of numbers that this returns a random number for? So first, let's look at the minimum. So 0 is the minimum for math.random, right? So let's assume that this returns 0. So 0 times 10, that's 0, plus 5, that's 5. And then when we cast this to an int, 5 is already an integer, so this would just return 5. Let's say we had 0.9, however. So 0.9 times 10, that would be 9. And then plus 5, that would be 14. And then when we cast that to an int, that would mean we would get 14. Because there's nothing after the decimal to truncate, so we would just get 14. So in that way, using that method, we can see that this would return a random integer between 5 and 14, which is like what we wanted earlier, right? So that's a good example of what math.random actually does. Alright, there's a lot of text on this slide, but let's break it down. So when we're executing methods, first we will call the main method by default whenever we run our Java class, right? So when we do Java like bank account, we were running that main method. That was our previous type along. If you weren't there, you might want to go back to that, but I was just using that as an example. Our second step, lines of code will be executed from top to bottom in general. Keyword being in general. So when you have methods, right, we would start at the top of the method and then we would execute to the bottom. We covered loops last time. In that case, like, we would go from top to the bottom of the loop and then we would go back to the top of the loop until that loop was finished running. But after that, we would go to the bottom of the loop and then go back down. And then writing a method name with parameters, if there are any, is known as calling the method. The computer jumps to that point in the code. So we'll see this in our type along on how when we can call a method, the computer will jump to that point in the code and then it will execute the code only in the body of that method, and after it's finished reading a method, the computer will jump back to the point where it had left off earlier. So there's like a essentially, like, I'm not sure what the word is, but we're like jumping around different points in the code and then going back to wherever we started. So that's kind of how the functionality of object-oriented programming works. And this is like really useful because we can like define little like snippets of code and then we can reuse those in our program. So yeah, let's move on. Method notes this is kind of like a summary of what we just covered. So object-oriented programming will allow us to take advantage of re-existing methods. Like if you remember polymorphism, this was what the idea of that was about. And then we'll be able to design methods with abstraction in mind. So abstraction is like allowing users to only use whatever they see, right? Like remember the phone example? A user doesn't need to know how their phone works to be able to use it. Just like that, we'll define methods like, if I go back, we'll be able to define methods like this without letting the user know how these methods work. So if we wanted to print my name, we would just like put this functionality in here, but we wouldn't reveal to the user how that functionality works. Alright, let's go back. So yeah, that covers our 3 main points on this slide. Polymorphism is, that main concept that we were learning regarding object-oriented programming, and it's something that will be useful for us. Alright, so let's do the type along. Actually, I'll let you guys do this first so that you can first try this on your own and actually know how it works. Get some practice with classes, objects, and methods before we get the answer. So first open your editor and then create a program called dog.java, because the class name will be dog, and then follow the instructions here. So it says write a dog class with 4 field variable names, name, breed, color, and weight, and choose the appropriate data types for each. Like, you wouldn't make name a number, right? Because a name would be something that you would type. And then initialize each variable inside a constructor as we did before, and then create a bark method that simply just prints wolf. So I'll give you guys I think we have some time, so probably 7 or 8 minutes. 8 minutes sounds good. I'll give you guys 8 minutes, and then I'll come back after that, and then we can check our answer. I forgot to unpause the recording while I was explaining the dog class, so I'll just do it real quick. So when we made this dog class, for this prompt, the first one, here's the answer. So we have our dog definition, our class definition, and then we have our field variables that have the appropriate data type right here, string, 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 and then double, and then we have our field variable name, right? And then we have our constructor. This is the initialization state, and in this we are creating these parameters that will be used to be set equal to our field variables. This is so that we can access our field variables throughout the entire class, but we can't access our parameters through that entire class. So if we try to print out breed in, that wouldn't work because it's only defined within the scope of this constructor method. That's why we use field variables. Lastly, I just defined this bark method as it was required in the prompt, using the access modifier, the return type, and then the variable name. And then we always have parentheses for methods. And then here, this is all it asks us to do. We just need to print wolf, and then that's it for the first type along. Alright, I was just resuming the recording, but now let's go on and see how we can actually implement this as well. So for this next part, we talked about how to define the class just now. We can just say class application like this. And we have our application class right there. Then it says write a main method inside of this class. So you would say public static void main, and then same thing as before, string array args. Then inside main, first create a new dog object called roughs. So you could say dog roughs equals new dog, like that. And we're getting an error immediately, and this is because the constructor dog is undefined. So you might see this error. What this means is that our constructors right here, we only have one constructor that accepts these parameters. So you will need these parameters right here. The thing about Java is that you can declare multiple constructors, so you could also say public dog like this, and this would be entirely valid. And you can see that our error actually goes away, but that is not what we're doing right now. So we don't need to worry about that. We should actually like define these variables because that's what the prompt is asking us to do. So it says inside main, first create a new dog object called Ruffs. Using this info, initialize Ruffs properties. So it says name is Ruffs, so we can make that a string because that's how we defined our constructor. And you can see here that it also gives us our constructor. So this is like a really useful feature of VS Code. I think Genie also has it, which is the editor that Monte Vista uses. But yeah, so we can see we need a string for our breed, which is Corgi, and then the color is tan, and then the weight is 26. So that's how we make our Corgi object, or rather our dog object, because the class is dog. And this is like creating the building that we used our blueprint to make. So this was our blueprint, and then this is our building, our house. In this case it's a dog, so it's different, but the same like concept still holds. Then it says call the bark method. So the way you would do this is by saying ruffs.bark. So yeah, it's fairly simple. That's all you needed to do for this type along. And be sure you have your semicolons also. But yeah, that should be it for this type along. There's nothing else. I guess we're done for now for this class actually. Next class, let me see what we'll be covering. We'll be doing, well, according to my like tentative schedule, it's not entirely finalized, but I think we'll be doing error handling and file input output, file IO. So yeah, that's it for next class. And if you have any questions, you can stick around, otherwise you're free to go. See you all next time.